Okay, so this is going to be a very quick tutorial on how to do the significance test of 53 in the book. Yeah, so let's just begin. Okay. Okay, so let's first draw the two normal curves. As you can see, I already kind of drew the normal curves. I realize that they should be tapering off at the end, but Paint doesn't really let you do that, so just go with it. Assume these are two normal curves. These lines are going to be the exact middles of each one, so you should know that the two curves are centered at 2.2.0, as they said in that's the original one. It's 2.0. Then basically you're testing the significance of 2.5. So with that, you can now just basically, what you need to do is you need to realize that since it's two-sided, you have to take into consideration both tails. So if you have both tails, you're going to need to basically either use the confidence interval or find the significance level. The significance level and the confidence interval in this case will be the same. So I'm just going to use a confidence interval, but you can also use a significance level. And so basically a confidence interval, as you should know, is the z is plus or minus. Wait, crap. I might be getting the equation itself wrong. Let me check if I'm writing the equation right. Yeah, that'd be awkward if I was using the wrong variables. Although I do know what the hell it is. Whoops. Heck retarded. Yeah. I knew I was doing something wrong. That's not z. It's supposed to be x bar plus or minus the z asterisk star, whatever you want to call it. And then the standard deviation, which is theta over the population. I mean, not population. The square root of the sample. In this case, you have the x bar in this case will be 2.0 because that is the you're trying to find the two alpha regions basically, and they'll be on one side and on the other side like this. So it'll be 2.0 plus or minus. What is the z going to be? In this case is going to be 1.96. The reason why it's 1.96 is since it's a two-sided and it's going to be, since it's 5% significance, that's the equivalent of a 95% confidence interval. And a 95% confidence interval of a 2, you have to take it from the highest value, which is 7.5% basically. Because realize that there's going to be a 2.5, then there's going to be the 95% confidence, and then we're going to have the 2.5% again. Okay, then using that, what? No, I'm not talking right now. Well, yes. So then using that, you're going to have the standard deviation. Okay, then the standard deviation as was given is 0.1 divided by the number, the sample size, which was 50. And then doing that, this should equal a confidence interval of 1.9723 and 2.0277. So with that, now you know what these significant levels are the same thing as the confidence levels in this case. So the significant level for this one would correspond with this value, and the significance value of that one would correspond with that value. Okay, so now you have that. So now what you're trying to find is the beta value. And beta happens to be equal to type 2 error. And if you remember from the notes, type 2 error is basically the region where you should reject, where you don't reject it when the value should have been rejected, right? Shit. Nah, fuck. Why am I so bad at saying these things? I'm pretty sure that's what it is. Yeah. It's when you should have rejected it, but it's like you failed to reject it, but you should have rejected it, basically. So the ha is true, but the ho, in this, you accepted the ho, but the ha is actually true. And so what region is that? That is this region. It's the area underneath the alpha. It's the area to the left of the alpha value. Yep, so it's this area. But what's important is the fact that since this keeps curving down, it goes all the way here, but stops. As you can see, it's going to stop. Like once you get to this alpha level, now you're going to be outside again, and then it will be significant again. So you only want the region between these two alpha regions. The significance levels. They have to be between these two significant levels. So then what does that mean? It basically means you want this area, so now you're just going to use a normal CDF to find that area. So normal CDF. And the values will be, as you should know, we calculated the two significance levels. It will be the lower bound, which is 1.472 We're going to have the upper bound, which is going to be 2.0277. Then we're going to have the mean, which in this case, do realize it's, oh, whoops, I just realized I put 2.5, but it's 2.05, my bad. It's going to be 2.05. Do you realize the reason why it's 2.05 and not 2 is because you're trying to find the region based on this curve. You want the area under the curve here, not this curve. So you take that, and then you're going to have the same standard deviation of 0.1 divided by square root 50. If you plug that into your calculator, which I will do right now, if I can find my graphing calculator, and I will see what the value is, but I'm pretty sure it gave me the correct value on the book. Let me see. Normal CDF, 1.4723, comma, 2.0277, comma, 2.05, comma, 0.1 divided by second root 50. And then I get a value of 0.0574. And then on the book itself, the answer was almost that. It was 0.576. So it's probably because it's probably some sort of, like, one of us rounded differently. So theirs is 0.056, ours 0.74. It's pretty much close enough. It's probably just a rounding error that caused them to have this value. So yeah, there you go. That's how you would do this problem. Okay, bye guys.